Good evening, all.
Good evening, sir.
Okay, by any chance, you got the material package? Anyone? Okay, no problems. I think today it will be shared with you. So in our last session, I just took you through, what is Power BI, how it looks, a couple of examples, right? Today we'll see, as mentioned, we'll go through the SQL concepts first. We'll try to understand SQL first, and then we'll move on to Power BI. That's the plan. Okay. So today, tomorrow, we'll talk about the SQL fundamentals. What is SQL? Why is it needed? And things like that. And then the real time, the reporting profiles, how they look, right? So this is a material package, and it will be uploaded to Google Drive, and from there you can download it. Okay. Fine. Just a second. So let's start with the reporting profiles or data analyst profiles, how they look. Okay. We'll start from there. Okay. So we may be doing a lot of reporting using Excel or any other reporting tool or Power BI, ClickView, Tableau. So many tools are available in the market. And as part of this training program, we are learning Power BI. Okay. But like Power BI, we have ClickSense is there, ClickView is there, Tableau is there, Google Data Studio is there. Different tools are available. But why we learn Power BI only? There are reasons. I'll explain that. How Power BI is different from other tools and what kind of advantages are there and how easily you can learn this tool. I'll explain all those things. But for now, let's assume that all of you are coming from Excel background. You all are good with Excel? Formulas. We understood lookup formulas in Excel, right?
Yes, sir.
Yes. Pivot tables in Excel. Got some idea,
Yes.
right? Okay, so that is enough to learn Power BI. But let me tell you one more interesting thing. In Excel so far, the data is already there in Excel, and on which you wrote formulas, on using which you created the pivots, or you applied conditional formatting, or you did the data validation rules and all these things. Data is there in Excel, and you created reports in Excel. But in the real time, the data may not be there in the Excel formats. Data may be there in a database. It could be SQL Server database, MySQL database, Oracle database, SAP database, right? You have Teradata, DB2, Sybase. There are different types of databases available. Okay. There are reasons why these companies prefer keeping their data in the databases only. Any guess why they prefer databases only? Why not Excel to store the data? They can store the data in Excel also, right? But why databases only?
Large data.
Large data, right? In Excel, we have security, yes, yes. So managing big teams and the data security is not that easy. But in databases, we have all those security rules available, and you can create the user profiles to access only some set of data, right? So that's the reason all these big and mid-scale companies, they prefer storing their data in the databases. And one more thing, Excel has a data storage limitation, right? In one sheet, how many rows of data you can store? 10,48,576, right? That's the max. And can you increase the number of rows in Excel? No, you cannot do that, right? So if you want to store, few more additional rows, you need to take another sheet, and there you can, save it, but you cannot, increase the number of rows in Excel, right? So in Excel, there are certain limitations, and also the security wise, Excel is not so safe in terms of like, you can break the security of Excel if you want using macros. Okay. Though you protect the sheets and all, you can still break them with the help of macros. But in the databases, it's not that easy to break the database security. Okay. Fine then. So that's the reason most of the companies, to store their data, they prefer databases. So one of those databases, is SQL Server databases. Okay. In our training program, also we cover SQL Server only. That's fine then. So here we go. You want to create a report using Excel or Power BI or any other tool. But for that, what is the very first thing that we need? Data. Perfect. So you need data. And the data in the real time is available in the databases. Right. Okay. You want to create a report using Power BI, but the data is there in SQL Server database. So you need to extract the data to get the data into your Power BI. So the most commonly used language is SQL, structured query language. Okay. Using which you can query the data from the database with the help of a DBMS, database management system. So the database management system here is RDBMS, actually, relational database management system. Why? Because all these databases, they store the data in the form of tables that have the relationships. So that is the reason we call it relational database management. Okay. So you want to create a report using Power BI. For that, you need some data, and the data is there in database. And using a language, you can extract the data into your reporting layer to create the reports, right? So SQL is needed for so many other purposes also, but from the data analyst standpoint, let us only talk about how to do the data retrieval. That's it. How the database security is managed, how the users are managed, how the data is inserted or updated or deleted. We are actually little bothered about them because that's not our primary role. We may want to learn those topics also, but we actually don't do anything with those things in the real time. Our job is always about data retrieval and use it for our reports and create the dashboards and all, help the business to understand what's happening in the business, right? So that's what we do. So SQL is again a very important language if you want to interact with any of the database servers to extract the data. That is what we are going to do. Right. So why SQL is needed? If you want to interact with the database, SQL language is needed. Right. So let me keep it simple for you to understand SQL in a bit more easier way. For this, let's talk about a restaurant example, okay? When we go to a restaurant, so you want to get some food, okay? So what is it you do? Directly go to the kitchen and place the order. What is it you do? We check the menu and we go to the kitchen and we talk to the chef. What is it we do?
We order something by calling.
Calling who?
Calling server.
Server, perfect. Yes, you use the right word. We call the server and we talk to the server. What is that we want? And the server job is to go to the kitchen, explain what you as a customer you want to the chef inside, and that person prepares the food and gets it delivered to you. That's what the normal process, right? So consider this entire restaurant example as a database environment. Okay, so entire restaurant is a database environment. You as a customer, right? Nothing but you are a client. You're a client, right? And you talk to the server, right? Server is our RDBMS. It could be any kind of a server, Microsoft SQL server, Oracle server, IBM server. It could be any kind of a server, right? So you talk to the server. So let's say you visit any Hyderabad restaurant and which language you use to talk to server? Malayalam, Hindi, English, Telugu, right? Why do you use that language only?
They accept that language.
Popularly. Okay, okay, fine. Maybe the popular is the word that you use, right? Let me stick to it for some time and let me explain it. I'll go to a restaurant, a very local restaurant, and I'll use US accent English, okay, with that survey. Popularly used language. You're not looking at actually what is popularly used. You're looking at something that is commonly understood. Right. So you talk to server, maybe in Telugu, Hindi, Urdu, or English here in Hyderabad, but the same thing if you go to any other place, you use that language, right? Similarly, if you want to talk to a SQL server, you need a language that is understood by the server, that is SQL. So all these servers, they understand a common language, which is SQL. right? SQL, structured query language. The very same reason why we talk to our restaurant server in a commonly understandable language, we talk to our SQL server also using a common language, which is SQL, structured query language, right? Perfect then. So you talk to server and you place your order, you want this. Let's say you want normal Hyderabadi biryani, okay? Right? How long will it take? Maybe 20 minutes also, yeah, it's a big number. Maybe 5 minutes. Why? Because everything is like well prepared there. And just like serve it, right? You just go and there, get it there. That's it. Right? So that means if your query is easy, if your request is easy to serve, a server response is also very fast. It goes there, gets us the food, and comes back and delivers, right? That person. So in here, the SQL server, when you place an order saying, okay, I want employee table, goes there, gets us all the employee data and shows it in our reporting layer. That's a job done. But the complexity increases here when, if your requirement is very, very specific and customized, okay, you want biryani, but less spice, right? And you want to add something extra there. And you also want to include something else. And you want to, have a little, a specific weight. You don't want more or you don't want less. You see more number of requests when you place with, a lot of complex requirements in it. Then obviously your server will take more time. Yes or no? Let's say if something is already available in the menu card, it's very easy. But when you make it like more customized one, it will take more time. Simple, understand this. When you place a very complex request to the server will also take some time to process that request and get it served to you, right? Same thing. When the server takes this request from you as a client, and you talk to the server and you place an order, and the server goes to the kitchen, right? Here the server goes to the database. So there in the kitchen, what is that we have? Let's talk about kitchen only. I'll come back to the database later. You have all the ingredients there. Different, material, raw material and all those things, right? So if you translate the same thing into the database language, that means all your tables, views, security rules, right? All those spices and all those things are there in the kitchen, right? Same thing in the database, you have the tables, views, stored procedures, custom functions, user-defined functions, all these things are there in the database. So basis on the request you placed, it needs to combine all those things, right? Let's say you want to get some food, okay? Let's say some fried rice. So you need rice, you need, a few sauces and all that. So you mix up all those things, right? So in the database side, you need to mix up all those tables. You know what is that we do there? We do the joins, we do the aggregations, we do the group by, we do the sorting, right? All those things, once we do that, final product will come to us. Like in the restaurant, we get our food. Here, we get our data set. We call it result set. We call it data set. Right? You simply call it as a result set or data set. It's up to you, okay? So fine then. So we as a client, we are using a reporting application. We want to use SQL, a language, talk to the server, get the data from the required database. And once the data is there into our reporting layer, then we'll create reports using the data. Understood? Why SQL is needed, right? So there are so many things in SQL, but as we are starting Power BI, as I said, today, tomorrow, I'll explain a few of the things that are needed to understand SQL. Later, you can learn a full-fledged SQL course also, okay? Done. So we understand that SQL can be used to retrieve the data from the database. But when it comes to the real-time databases, you see two types of databases, OLTP and OLAP. Okay, OLTP and OLAP. So these two are designed to serve two different purposes. Okay, let's talk about one by one. So the basic OLTP, which is nothing but online transaction processing, OLAP, online analytical processing. What is this online transaction processing? This transaction processing, as the name says, it manages the transactions, right? The best example of OLTP, you can consider any of the billing systems. Let's say you go to a shopping mall, there you see a billing counter, right? All those billing systems are connected to OLTPs only. They are there to process the transactions, right? Every customer goes to the billing counter, does one transaction with the system, right? So all those things are inserted are nothing but, a new row is created inside the database tables. If you buy something, that means you are inserting a new record in the database table. That's what happening there basically. So OLTP basically to manage all those transactions and database modifications. And the focus of OLTP is to insert, update, delete data. A simple thing. Let's say you go to a shopping mall and you pick up a couple of dresses and you go to the counter, right? So when you hand over those dresses, that person scans the QR code. I mean, the barcode usually, not the QR codes there. Barcode, and the product details will be displayed on the screen, and how many quantity you are buying and what is the price and the total bill, right? And once you make the payment, a bill gets generated. You know what happened there? One transaction happened there. So-and-so customer with so-and-so customer ID. These are the products, bought from us, so-and-so date, so-and-so time. This is the value of the products, and every bill comes with one unique identification number, bill number, invoice number. We get that, right? We'll also talk about the IDs in the next, maybe in the next few minutes, right? So what's happening there when you buy something from a shopping mall? It's basically an insert query is hitting the database. Insert, right? A new record will be inserted, right? Then what is update? Let's say while that person is taking your details and all, you found your mobile number or email address. Your email address is still, old email address is reflecting in your customer profile. Can you ask that executive, okay, I'm not using that email address. Can you change it? Can you update it? Is it possible? So you go to a billing counter. Your customer profile is there already. That person asks your mobile number. When that person entered your mobile number, hit enter, all the data is present, like your name, your address, your email address and all that. And you found that email address, you're no longer using it. So can you ask that person, okay, please, can you update my email address because I'm no longer using that?
No. Yes.
Can't we?
Yes.
That's your personal account, I mean, personal profile, right? You can ask. That's okay. I mean, I understand, if it is a bank or something, you cannot simply, place a request. You will have to probably, go maybe an authorized channel, but directly they cannot update your number or email address like that, right? But if it is a shopping mall, it's easy. So you just ask them and they will change it. Done. So which type of transaction is happening? It's an update transaction. So you got your record updated, right? Then what is delete? Let's say when you saw your profile, there you find two addresses. One is your home address, the other one is office address. And you actually moved out of that office and now you joined a different place and no more, you are not, using that office address. So can you ask that person, okay, I don't need that address, office address, please, can you delete it? And you just keep only my home address there. Is it okay?
Yes.
Yeah, possible. If it is, if the billing counter executive has the permissions to, delete that, that person can delete it. You got the point. So insert, update, delete are the, is the primary focus of OLTP, online transaction processing system. The best example is a billing counter. You can also consider ATM. ATM is also OLTP. Why? What happens there? Transactions only, right? What do? We, withdraw the money, we deposit. I mean, if it is like a machine that accepts money to be deposited, we can even deposit money there, right? Okay, tell me something. You go to ATM, right? You withdraw the money. Let's say you got like 50,000 in the account and you withdraw 5,000, right? And the amount gets updated to 45,000 because you have withdrawn 5,000 there, right? Now tell me what kind of transaction is it? Is it insert transaction, update transaction, or delete transaction? Update. Online, what do you think about this? When you withdraw the money, your money, gets debited and your balance gets updated. So what kind of transaction is it? Is it insert, update, delete?
Update.
Transaction is done. Then insert only. Insert.
It's actually insert. Yeah. So today you see your account with 50,000. Tomorrow the balance gets updated directly to 45,000. And it doesn't leave any track where that 5,000 went. You get the point? So that means basically it's an insert transaction. Insert transaction, there is a new record being inserted that you have withdrawn 5,000 and after deducting the 5,000, your balance is 45,000. So your balance doesn't get updated directly from 50,000 and the very next day it shows 45,000. No, it shows an additional record that you have withdrawn so and so money from so and so ATM, so and so date time. And then after that, the final balance is 45,000. You understand? It's not update. Bank records, especially the transactions, they do not get updated. There are only insert statements. They do not get deleted also. Can you delete a banking transaction? No way. So the databases, rightly mentioned, the security. You cannot simply, in Excel, it is like very easy. If you don't want any of the record, just do a right click and delete it. But in the database tables, that's not possible, right? Once something is entered, if you really want to reverse it, you need to process a reversal transaction, but you cannot simply delete that record, right? Let's say 5,000 accidentally, debited. What it needs to do, if it needs to be credited, you cannot delete that record. You need to pass a credit entry to again match the value. Reversals can be done, but not deletions. Remember, a few of the tables are like very secured, right? Perfect. So that's an insert statement, not an update statement when you withdraw the money, right? So when you come to this data, OLTP and its transactions are the original source of data. You need to understand this. What is original source of data? This is where the very first transactions, first transaction that takes place, right? If a transaction is there, that gets recorded in the OLTP only. Later, it will be cloned to or copied to OLAP. I'll talk about what is OLAP later, okay? So this is where the actual transactions are done. All the data is stored in the OLTP systems. And OLTP is, they got the short transactions. You know why they are short transactions? Because it's only about insert, update, delete. Simple, easy transactions, okay? As these are short transactions, they take comparatively lesser time. Short, right? Because these are simpler queries. Okay, these are simpler queries. We don't use complex queries here. Simple insert, update, delete. Okay, so I'll talk about normalization and data integrity in the next example. Let's move on to OLAP, online analytical processing. This is another system that is available in our real time. So this is basically to do the data retrieval and data analysis. You should get a question. You already have all the data located in the OLTP. Then why do I need to have a separate system to do the data retrieval? I can also do the data retrieval from this, right? Because the data itself is stored inside this. Why do I need one more system? I'll explain it shortly, but listen to it. For now, it is a data analysis system. What is the purpose? What is the focus of this? You need to extract the data for analyzing, and so that it helps in decision making. Right? In decision making, we use this data, whatever the data we extract. Different OLTP databases data becomes the source of OLAP. Nothing but multiple OLTPs. I'll give you a simple example. Let's say you're working with take Reliance Fresh kind of a thing. Okay, Reliance Fresh. You have so many billing systems there. Let's assume that Hyderabad has one data center. All the Hyderabad, Telangana, AP, all the data is stored in Hyderabad data center. One OLTP database. Okay. And you have Chennai, you have one more data center. Bengaluru, you have one more data center. Each state got one data center, okay? So someone who sits in Mumbai, who is a CEO of the company, wants to see what happened yesterday, entire Reliance Fresh. What is my total sale value, right? When this person wants to see the overall value, but the data is located in their decentralized, OLTP databases. So this person needs to interact with, Bengaluru data center, let's say Chennai database, Hyderabad database, Kolkata database. But here's the point. We don't do the real-time reporting like this. What is it we do? We get a consolidated from all these databases and load that into one data warehouse. You would have heard this data warehouse. What is a data warehouse? So basically it gathers the data from different OLTP databases and keeps it in one warehouse, right? So how is it possible? Like, who does this? Who gets all the data from the different OLTP systems into one OLAP? There is a team called a data engineering team. These people have roles. One of those roles called ETL developer. You would have heard this ETL developer: extract, transform, load. So they extract the data from the different OLTP systems. They transform the data into the required shape. and they load the data into one OLAP, like a data warehouse. They load all the data from different OLTP systems. So your data warehouse is a central repository of your data. So all the databases data is now available in one place. So what is the advantage? Whenever I want to create any report, I just connect to only my data warehouse. I no need to interact with 20 different individual databases. All these databases data is now located where? In one data warehouse. This is all okay, but if I want to get only Hyderabad data, I can directly connect to Hyderabad OLTP and I can still read the data there, right? Why do I need to wait and things like that? Understand this. These OLTPs are already busy in serving the customer requests, right? So many transactions may be happening at this point also, let's take an example of Amazon. Someone may be booking an order at this point also. Maybe every second there may be a good hundreds of transactions may be placed. So all those transactions are handled by the OLTP systems. On top of that, if you want to perform any analytical thing, okay, it definitely kills or hampers the performance of your system. I can prove it easily. All of you got papers with you, rough papers, right? Okay, I'll tell you one thing. Make a note. I'll give you a few numbers. Okay, make a note. Yeah, we'll try two of you. That's fine. Write these numbers: 12, 16, 20, 24, 28, 32. Okay, I said 12, right? Okay, what happened just now is data entry. Nothing but all these things are insert statements. So you just inserted that data into a plain sheet, but here we got it into a database table. You inserted all those records. Fine then. So I said 12, right? Change it to 10. Remove that 12. Change that to 10, just 10. So what happened there?
Update.
Update is done, right? I said 16, the second number, right? Delete it, we don't need it. Right, what happened? Delete happened. So in this process, you did insert, update, delete, right? And I think I stopped at the 32, right?
20.
20?
32.
32, right? Yeah, right, 36, 40. So what's happening now? Inserting, right? Okay, here we go. I think you are comfortable, right? Doing it. Do the sum of first three numbers, which is 10, 16, 20. Do the sum there and let me know what is the sum. And while doing it, do the sum of fourth number, eighth number also. And while that is happening, I stopped at 40, right? Write 44 and 48 also. 44 and 48. And I said fourth number, eighth number sum, right? This time you do second number and sixth number sum also. What's happening here? You are parallelly inserting the data, and also I'm asking a few arithmetic questions and you are trying to solve them as well. Now I think you should be finding it a little challenging. I still didn't get the first question answer. 10 plus 12, 16 plus 20, how much? The second question, 4 and 8 position values. You figured out what is the fourth number and eighth number there? Yeah. Score total 64 is it?
64.
That's right. Are you finding any challenges there? Earlier it was kind of easy, right? I was just only asking you to write it, change it. But while that is happening, if I'm asking you a question about, okay, do this calculation, get me the sum, get me, average of this, I want to understand the total of all those numbers. You found it challenging? But let's do it in different way. Yeah. You will be only entering the data. And you will be doing the modifications. And you will be doing the calculations only. You find it much more comfortable? Understand? He'll be entering only the numbers. And looking at the numbers, you just do the calculations. Would you find it easy? Earlier, I made you do both the tasks. You're writing the numbers, you're updating the numbers, you're doing the calculations, both of you. But this time I'm saying, you just take care of writing the numbers. And you just take care of looking at the numbers, you do the sums. Which one is easy? The previous one or this one? Now I'm giving you two different responsibilities. You just write the numbers. You just do the sum. Definitely the second one is easy. Earlier, I'm asking you to do both of them parallelly, right? But this time I'm, giving two different responsibilities. Understand this. The OLTP system job is to insert, update, delete. OLAP system job is to do the data retrieval, and that helps us in decision making, right? We write the complex queries to do the aggregations and things like that. So when we have two different systems, one system is engaged in only serving the customer request, insert, update, delete. The other system is engaged in only doing the decision making work. You understood why two systems are there. You can actually connect to the OLTP also to do the, these decision making work, but not recommended. Why? Because the system is already busy in processing a lot of transactions. Now you get it. Why do we have two different systems? You understood? So one system's job is to insert, update, delete. The other system job is to only retrieval and decision making, right? So how this OLTP data can come into OLAP with the help of ETL developers. They build the data pipelines. You would have heard this. Data pipelines, okay? They create data pipelines, and this process is called ETL, extract, transform, load. The job of ETL developer to extract the data from the OLTP, transform the data into required shape, and load the data into one OLAP, which is our data warehouse, okay? Which manages our data warehouse. Yeah, OLAP has long transactions. Why? Because these are not simple insert, update, delete transactions, right? What is it you do? You want to get last 6 months sales information from, let's say, what do we call? Let's say FMCG, right? FMCG, in FMCG sector, last 6 months sales transaction only in Hyderabad, store code is 1101. When you give all these conditions, definitely it will take more time to process that request and filter the data and get you only that sales information, right? So that definitely takes more time because the complexity of the queries increases here. So as a result, this takes more time. OLAP transactions, they take more time because of the complexity of the queries, right? So the two types of systems are there, OLTP, OLAP. OLTP systems, who use it? Any idea? If you look at the billing counter, so that role, the billing executive, it's like a data entry role. So what do? Basically, they do data entry, right? SAP users also, there are end users of SAP. What do they do? Data entry. That's it, right? Okay, so OLTP systems are used by the data entry operators. As a data analyst, which system you use? OLAP. OLAP. Right? As a data analyst or a reporting analyst, we connect to the OLAP, right? That's the reason we get access to the data warehouses, right? We rarely work with the real-time transaction systems, but most of the times OLAP, which is like a data warehouse, and we write so many complex queries to retrieve the data and use the data for the decision-making process, right? I hope you understood why two types of systems are there. Where is the data initially recorded? Correct. The data is initially recorded in OLTP and then it is loaded into OLAP, right? So what is that process of, moving or copying the data from OLTP to OLAP is called?
ELT.
ETL. We extract the data, we transform the data, and we load the data. Okay, tell me something. Is it done by the data analyst? ETL process?
No, data
No. Data engineering team. There is a dedicated role available, which is ETL developer. There are different tools available in ETL, Informatica, Talent, different tools are there, right? So initially, this is how the process, this is how it starts. Database developers, they design the databases. Once the databases are ready, the data entry operators, they input the data. Once the data is ready in the OLTP, the ETL developers, they get all the different databases data into one central repository, which is our data warehouse. So that once the ETL job is over, as a data analyst, our job starts, right? Because all the data is available in one place, and what is it we do? We extract it and we try to analyze it, right? Make sense? Two systems. Why two systems are there? Okay. What is normalization and what is data integrity? In the next examples, I'll explain, but I hope you understood the two types of systems. Okay, tell me something. Do we also do any data entry?
No.
No. So what is that we do? We only do data
Plans.
analysis. Are we sure? We only do data analysis. We don't do any data entry. Sure. No? Okay. How many of you did a GPay, phone pay transaction today? Any UPI transaction you did today? Yes. You know what did you do there? Data entry only. I understand you may be thinking only from the company standpoint, once you join a job, then yes, you are a data analyst. But as every day we do a lot of data entry. Yes, we do a lot of data entry. Earlier, understand this, earlier if you want to transfer money from one bank account to the other bank account, you know what you used to do?
Yeah.
So when the common, core banking system is not available, during I think 2008, 9 sometime back, then they actually got all those banks into a common core banking system, and wherein the interbank transactions started happening. Prior to that, it was not that easy. You need to visit the bank, submit a form that from so and so account to so and so account you want to transfer the money, and that's how it used to happen. But now everything is on the fly because of the availability of the internet and all. But yeah, earlier bank employee was a data entry operator for us. Now we are only the data entry operators. If you want to, book any train ticket earlier, when the online platforms were not there, we used to go to the counter and there was a data entry operator, right? But now we are entering all our data. You're getting the point? So we also do a lot of data entry, but in the, maybe once you get placed, usually the job is to do the data analysis, not the data entry. Okay. I'll explain what is data normalization and data integrity, but I hope all of you are clear about the above points, right? Online participants, is it clear?
Yes, sir.
Yeah. So moving on to the next one. Okay. Let's take a look at this table. This table answer these few questions. Can I find out the total salary paid by the department? Is it possible? Total salary paid by the department. Is it possible? Yes. Yeah. What is it you do? Total salary paid by the department. Each department, what is the total salary we are paying? What is it we do? Yeah, we can use a pivot table, right? So everything is there in one place. We just quickly create a pivot table like this and just keep the cursor there, go to insert and a pivot table, click OK, and simply track each department, right? So keep it here and salary, keep it here because it's currently showing the count, and change it as sum. That's it. Each and every department, what is the total salary we are paying? So can I answer one more question here? Each designation, each job wise, what is the total salary we are paying? Can we do that here? Is it possible? Each department, total salary paid. Is it possible? Oh, sorry, each designation. Designation is nothing but the job. Each job, total salary paid. Is it possible? Total salary by the job. Is it possible? Possible? What is it you do? Same like a pivot table and keep the job in the rows and the salary in the values as a sum. You will get that. So these questions, you are able to answer it directly, right? Okay, I have one more. The total salary paid by the gender. Is it possible? Total salary paid by the gender. Is it possible? Yeah, why? Because gender is there, salary is there. Yeah, just create a pivot table and you will get the answer, right? Yeah, so all the questions are answered using a single data set here, right? But I'll move on to one more, and here you need to answer this. Look at this table. Only this table, okay? Don't look at others. Only this. Can we create the total salary paid by the department name? Is it possible? Using this table, I want the department name wise total salary paid. How much is accounts paid? How much is HRD paid? How much is sales paid? Is it possible?
This table, there is one.
Right, in this table, we don't have the department. But do we have anything in this table that helps us in fetching the department name from the some other table?
Yes.
Department ID.
Exactly, department ID is a common key between both of them, right here and here. And you know this very well. Using this department ID and this department ID, if you want to fetch this department name, what is it you do? Equal to we look up. And you know this, right? Department, yeah, table array. And as soon as we select any array, we freeze it and it's there in the second column at 0 and close it. Right. Now, can I do this? Department wise total salary paid. Can I? Let me just change it as D name. Can I do this now? The pivot, is it possible now? Yes. So that means you are not able to answer this question using a single table. You are depending on some other table also. Okay, let me give you one more example there. Can I get the salaries paid by the job, nothing but the designation? Is it possible? Is it? No, not possible. Why? Because we only have the job ID here, but the corresponding job is here. What is it we do in Excel? I can do a VLOOKUP, right? Okay. So if you want to do any kind of such calculations, you are depending on other tables, using this job ID 1, you will have to look up that value here and find out what is it, right? And similarly, the other things also, if you want to do any department wise calculations, you need to look up that department value, right? The department number here, and you need to create a report, right? Similarly, gender wise, if I want to do the calculations, same thing. You need to use the gender and this, right? Earlier in this, you're able to answer all those questions using a single data set. But in here, you're using multiple tables to get one, answer, right? The difference here is, there is something called normalized data and denormalized data. Let's try to understand what is normalized data and denormalized data. Denormalized data is nothing but everything is there in one place. It's denormalized. But we usually don't see this kind of data in the real time. Everything is there in one place. No. Usually the data is available like this, where the data is split into multiple tables. This is called normalized data. Okay. Why do we do this normalization? Let's try to get some idea. Like, why do I need to split the table? Before even getting into this discussion, I have a question here. If you are a data analyst, which kind of data set you would enjoy the most working with? Denormalized data or normalized data? Denormalized. Denormalized. Why? Because everything is there. Everything is there in one place. You can easily create pivots. You can easily create any other formulas using the denormalized data. But you know what? In the real time, unfortunately, all our data sets are normalized data sets. Why do we need to perform the normalization? Very simple. You see this one. What is one? Job ID, right? Job ID 1. What is job ID 1? Right. Manager. Right? I can type manager here. And I can type manager here, manager here, manager here, manager here. right? Wherever one is there, I can type manager there. But understand one thing, if I'm repeating this manager again and again, the data is redundant. There is something called data redundancy. What is data redundancy? The same value is repeated for multiple number of times, right? There you get a question, even one is there, right? One is also repeated for multiple number of times, right? Okay, that I understand, but answer this. If I give you a pen and paper, I'll ask you to write one and I'll ask you to write manager. Which one consumes more ink?
One.
Manager, right? Yeah. One consumes very less ink. If you want to write manager, that consumes more ink. Nothing but if you are writing their physical values again and again, that means it is going to take more space in that table. Instead of that, if you can assign a simple a key, that key will represent that value only. Right? So how I can convert this key into its value in Excel? We use lookups, VLOOKUP, XLOOKUP, index match. In SQL, we use joins. In Power BI, we use relationships. In Power Query, we use merging. Different concepts are there. I'll take you through one by one. But Excel, you are comfortable, right? If the data is located in two different places, one common key is there. You can fetch it using VLOOKUP, right? Perfect then. So understand these keys will help us to reduce the data redundancy, and also it helps us maintaining data integrity. Okay, why? I'll tell you the second point. Can I give 60 as a department ID here?
No,
Why no?
there is no 60.
Exactly, there is no 60 in the departments table. As a result, you cannot use this 60 as a department ID here. Okay, so why it is not possible? Because that 60 is not there in the departments table. So if a department is not there in the departments table, that department cannot be assigned to the employee. It's as simple as this. Okay, so understand this data integrity. If a department is there, then only you can use it in the employees table. If the department number is not there, then you cannot use it, right? So by performing the data normalization, we get one thing is efficient memory management by reducing the data redundancy and inconsistency issues. And along with that, we can also maintain the data integrity. Incorrect values and all cannot be entered. Nothing but if a department ID is not present, you cannot use it. Okay, if a job ID is not present in the jobs table, then you cannot use it in the employees table. You cannot assign 8 here. Why? Because your job IDs are ended with only 7. You understood the point? So all our real-time databases are designed this way only. All our tables are normalized tables, and the data is located in multiple tables. When you want to create a report in Excel, you need to use VLOOKUP. In SQL, we need to use joins. In Power BI, we need to use relationships. Okay, remember this. Right. So you understood the entire concept, right? So when we perform this normalization, we get two types of tables. But you get a question like I see 4 different tables, right? One table now I'm able to split into 4 tables. Don't count them 4. There I see only 2 types of tables. Dimension tables and fact tables. What is a dimension table? What is a fact table? Let's try to understand. A dimension table holds categorical data. Dimension table holds categorical data. Nothing but locations data, department data, designations data, right? Territories data, products data, customers data, right? These kind of things, vendors data, suppliers data, these kind of things are called categorical data. So categorical data is there in dimension table. If you look at the departments table, I say this has categorical data. So it is a dimension table. Designation, this is also holding some categorical data. So I'll keep it as dimension table. Genders table, this also holds the categorical data. So I call this as a dimension table. you should get a question here, like, you are very much comfortably able to say that, okay, this is a dimension table, this is not a dimension table, but how do I get to know that this is a dimension table only? Very simple. You take a look at any table, at least one column in that entire table supports you to do the mathematical calculations is a fact table. If you look at a table, none of the columns support you to do any mathematical calculations, simply sum. If you can't do the sum on any of the columns, it's a dimension table. Can I do the sum of location? No. Text content, how can I do the sum? Can I do the sum of name? No. Can I do the sum of department ID? It may be looking like these are numbers only, right? Can I do the sum? Hold on, it doesn't make sense. Why? It is as good as, if you do your mobile number plus your friend's mobile number, what kind of result you get? It returns as such a big number, but what kind of a result you get? It doesn't make any sense, right? So understand that IDs are not numbers. IDs are only for the unique identification purpose. They are not numbers and they cannot be summed up. Understand this. These are only for the key purpose or lookup value purpose we use it, these IDs, but these are not numerical values actually, right? So if none of the columns allow you to do the sum, you can consider that as dimension table. Why? Because it holds only the categorical data. So designations table, is it a dimension table? None of the columns allow you to do the sum, right? But when it comes to the employee table, what is the fact table? At least one column should allow you to do the sum. So tell me, in this entire table,
Salary.
yes, salary column is there, and yes, you can do the sum of the salary column, sum of salary. Does it make sense? Definitely yes, right? What is the total salary to be paid to the employees? Yes, it's a fact table. So when you split the tables with the help of normalization process, you get two types of tables, dimension tables and fact tables, right? So these dimension tables and fact tables data can be brought together using the keys, right? Using the keys, common keys. Do you see the common keys? Between the employee table and department table, do you see any common key? Department ID, perfect. Between the employee table and designation table, do you see any common key? Job ID, perfect. Between the employee table and gender table, do you see any common key? Gender ID, perfect. So these common values in Excel, we call them lookup values, right? In SQL, we call them keys. There are two types of keys we discuss, primary key and a foreign key, right? So I think by now you understood why do we get more number of tables like this. Okay, why do we get more number of tables like this? To reduce the data redundancy and inconsistency issues, we split the data. Okay, what is the process called? Data normalization, perfect. So as a result of the data normalization, we got this, right? Okay, perfect then. As a result, we got the keys also. Now let's take a look at the keys. Take a look at this. We have job ID, right? The same job ID is here. Each and every job ID is there for how many number of times? Each ID is there only once. Okay, tell me, can any job ID be null like this without an ID there? No way. You will have to have a number. So understand this. If any column satisfies these two rules, the rule number one is everything must be unique. Rule number two, it can't be null. If both the rules are satisfied on any column, you can consider that as primary key. Okay. So if the value is always unique and cannot be null, is a primary key. Okay. The same primary key acts as a foreign key in some other table. You see this job ID? It's a foreign key, right? What is a foreign key? Foreign key is a primary key of some other table. So this job ID is a primary key of this table. So here a foreign key can be repeated. Yes or no? In the designations table, manager designation can be there only once. But multiple employees can be managers in an organization, right? You understand this? Multiple employees can be managers in one organization. So you see the same one, maybe for multiple number of times here. So nothing but a foreign key is a primary key of some other table, and a foreign key can be duplicated and can also have nulls. Let me show you this department ID, right? So a department ID in the departments table, this is which type of key? Primary key. The same primary key in the employee table is a foreign key. What does it mean? The same department ID can be there for different employees. Multiple employees can be part of the same department, right? Perfect. So, as I said, foreign keys can have null values, right? It's okay if a department is not finalized yet for one of the employees. That's okay. We'll leave it null. So, primary keys cannot be null and always unique. Okay. Foreign keys can be duplicated, can also have nulls, but one thing is that you cannot use a number which is not there in the primary key table because of the data integrity constraint. Understood? So what is a primary key? Something that is unique and not null is a primary key. What is a foreign key? A foreign key is a primary key of some other table. Is that clear? Okay, good. Looks like you got some idea now. What is a primary key, foreign key then? Right? Okay. Let me show you one example. Then you will get a bit more clarity about what is a primary key, foreign key. So normalization, denormalization, are we okay? What is normalization?
When we are
Splitting the data into multiple tables.
Correct. We split the data into multiple tables. That's a normalization. And as a result of this process, we get two types of tables. What are they? Fact tables and dimension tables. Fact tables hold. Fact tables hold
Any of the columns to deliver.
numerical data. Simply fact tables hold numerical data for the calculations. Dimension tables hold categorical data, right? Perfect. In the real time, what type of data we get? Denormalized data or normalized data? Normalized only. Nothing but, the data is there in multiple tables. In Excel, to bring the data together, what is the formula? Which one? Lookups, any kind of a lookup formula. In SQL, joins. In Power BI, relationships. Excellent. Okay, here we go. Take a look at this. Tell me which one is a primary key in this table. Yeah, I'll give you 30 more seconds. Think about it.
AID, employee ID.
Employee ID is a primary key. Okay, excellent. So
Pay ID also.
pay ID also. Okay, hold on. Usually in one table, one primary key is enough. We don't see multiple primary keys. There is a concept called composite key, but that's a different thing altogether. But usually one column only primary key, right? Okay, fine then. So all of you are saying employee ID is a primary key, right? Okay, fine then. So let's do this way. I'll mark this as a primary key, okay? Just hold on. All right, so let's do this. We'll mark this as primary key, okay? Right. So what is the behavior of a primary key? Exactly. Unique values cannot be null. Perfect then. So we marked employee ID as a primary key, PK, not Pavan Kalyan. Okay, yeah, it's primary key. Right, here we go. We mark this employee ID in this table as a primary key, and you know the behavior of a primary key, and it is always unique and cannot be null. Nothing but, I cannot duplicate it, right? I cannot write 1, 2, 3, 4 again. Yes or no? Yes, yeah. And I cannot keep it null also, right? Okay. Both the rules must be satisfied. But take a look at something. Take a look at the sheet name, employee payroll, right? In the payroll table, you marked employee ID as a primary key, right? So don't you see any issue if we mark employee ID as a primary key in the payroll table? Okay, payroll. Is it processed every month? Payroll. Yes. So that means in the next month also, the same employee should be paid, right? With the same employee ID. Nothing but I actually zoomed it. Let me apply the freeze panes. In May, 1, 2, 3, 4 is paid. In June also that 1, 2, 3, 4 should be paid, right? In July will be paid, August will be paid, but with the same employee ID, right? So that means if you mark this as a primary key, is there any chance that I can input one more 1, 2, 3, 4 here? No way, because I already marked this as primary key. So in the payroll table, if I mark employee ID as a primary key, you know what will happen? In the entire lifetime of that employee will get paid only once. I give you a recommendation here, don't join that company. You understand the point? What happens if you mark employee ID as a primary key in the payroll table? That employee ID can be there only once. It cannot be duplicated. You know that, right? Primary key behavior, it cannot be duplicated in that column and cannot have nulls. So if that is the case, 1, 2, 3, 4 cannot be paid. Not only that, if the 1, 2, 3, 4 employee to be paid with some bonus, that is also not possible. Why? Because 1, 2, 3, 4 is here, 1, 2, 3, 4 is here. You cannot duplicate that. And 1, 2, 3, 4 is here again. Yes or no? So you cannot mark this as primary key. No, this is not a primary key. Then what is the primary key here? Exactly. Pay ID is a primary key. Yes, each and every pay ID, every month it is unique. Right? For the same employees, it can be paid. Right? Using the different pay ID, we can pay same employee. Understood? Right? Okay, now you take a look at this. What is the primary key here? Yes, employee ID. Here in this table, it is a primary key because you are looking at employee table. Employee table, each and every employee will get one unique identification number. That's it. And now you tell me in the payroll table, what is this employee ID? It's a foreign key. Excellent. It's a foreign key that is coming from EMP table. Understood? Now you understand, you cannot say simply something is sounding unique. You cannot say, that is a primary key. Now you can't do that. Right? Now let's take a look at this. Tell me. Which one is a primary key? Aadhaar number.
Account number.
Aadhaar number, is it a primary key?
At least some people may have.
Hmm.
Also can be an everything.
Hmm.
So one may solve them.
Account number is a primary key? Okay, yes. In the bank accounts table, account number is a primary key. Yes, that is correct answer. It's a primary key, okay? You may be thinking customer ID or Aadhaar number. No. Why? Because one customer can have different types of accounts in the same bank. An SB account, credit card account, home loan, car loan, OD account, and all these different kind of accounts are possible for only one customer account ID, right? So the customer account ID, customer ID can remain same. But each and every account, SB account number may be different, credit card account number may be different, home loan account may be different, right? So those things are different, but the customer ID can remain same, and each and every customer, that Aadhaar number is same for the same customer. You understood? So you cannot say something just by listening to it, you cannot say something as a primary key. Right? Got some idea now? So tell me this. Aadhaar number. Is it a primary key? Aadhaar number, is it a primary key?
And what data or the table we are seeing defines whether it is primary or foreign
Yes.
key now, sir.
Absolutely right. Yes. You cannot say simply, Aadhaar number, right? You can't say it is a primary key. I'll tell you why it's not a primary key. See, the same Aadhaar number may be submitted to your bank for multiple number of times. So the same Aadhaar number may be repeated, right? That's not a primary key. There in the banking, records. But Aadhaar number with the Aadhaar issuing authority. So they issue each and every citizen of India with one unique identification number, that is Aadhaar. So every citizen gets one Aadhaar number. So with unique identification authority of India, that table Aadhaar number is primary key. Okay, PAN. Is it a primary key? Can that be duplicated?
One customer can use for multiple bank accounts. No?
Mm.
You can also.
Understand this way. Whenever I ask you a question, is it a primary key? You need to ask me a question in which table. Unless you know the table, you can't say it. PAN may be sounding unique only, but in which table you're seeing that? So PAN, in the PAN issuing authority table is primary key. But the same PAN in the IT returns table, IT returns. Every year we file the returns using the same PAN. Nothing but the PAN number will be repeated in the returns table. You get the point? So PAN in the IT, the PAN issuing authority table, it is a primary key, but the same PAN in the IT returns table is foreign key. Foreign key. Okay. Laptop serial number. Is it a primary key? In which table? Correct. In the production table. Laptop manufacturing table. Is a primary key. Why? Because each and every laptop that is coming out, that comes with one unique serial number, right? In the manufacturing table, it's a primary key, but the same laptop serial number in the service center table, foreign key. Why? Because the same laptop can go for multiple times servicing with the same serial number. So service center table, the same serial number may be repeated for multiple number of times, whereas in the manufacturing table, that serial number is there only once. Understood? I'll give you one more easy example. With that, you can easily remember of primary key, foreign key. All of you write bytes. Bytes, cars. You write them right. Okay, perfect. Now you'll understand it easily. Your vehicle registration number. In which table? Perfect. In the RTA table, who issues that registration number? Primary key, because each and every vehicle, they issue one unique identification number. Okay.
Service center we
have. Let me keep it in a little different way. Service center people, they don't really need your registration number. Yes or no? But someone else really needs your registration number. Traffic challans. Right. Now you understand this. In the registration department table, vehicle registration number is a primary key, but the traffic challans table is a foreign key. What if a vehicle is involved in multiple traffic violations? The same number is used to generate different challans. You understood the point? So something is sounding unique, you cannot say it is a primary key unless you know the table. In which table you are seeing it? Student ID. Okay, in the student admission table. Primary key, right? Examination table. Same student, right?
Foreign key.
Exactly. As the same student ID needs to write many exams, it is a foreign key there, right? What if we mark student ID as a primary key in the examinations table?
Only once.
He can write only one exam.
Exactly,
One
I always
subject.
wanted to implement that kind of a logic in database. But yeah, no one accepted it, okay? So that you write only one exam, all exams done, right? Anyway, system won't accept you to write one more exam because your ID is already existing there. You understood, right? I hope you got some idea how these tables are created, how the keys are created there. And especially primary key, foreign key. Why? Because using the primary key, foreign key only in Power BI, we create relationships. Okay. One to many, many to one, right? The relationship cardinality is there. We'll talk about that. So I hope you understood the concept of what is normalization, what is fact table, what is dimension table, right? So I'll build one data model tomorrow. You will understand just to give you some idea, like from the SQL standpoint, how these data models are there. And I'll also show you the schema designs, a star schema and a snowflake schema. Okay, how they look. With that, you will be very clear about the SQL concepts that are needed to build Power BI reports. But yes, once it is done, we'll move on to SQL sessions also. Okay. But yeah, up to this point, if you can understand primary key, foreign key, which table, these kind of things, then we are good. Right? Any questions? Online participants, do you have any questions? What are the two real-time systems we have? OLTP, OLAP. As a data analyst, which system we use?
OLAP.
Right. Which team helps us to get the OLTP systems into OLAP?
ETL.
ETL teams, right? Extract, transform, load. Right. It's their job is to get the data from multiple data sources into one data warehouse. Right. And one more thing, we don't get complete access to the data warehouse. Right? Data warehouse contains different teams' data. If you are a financial analyst, why do you need sales data or HR data? You're getting the point? So there are different teams, and basis on the roles and responsibilities, we get the access. In the data warehouse, a small subset. Data warehouse may have so many things, but as a financial data analyst, I just need a subset of financial data. Then this subset is called data mart. So we get access to the data mart zone, right? Not to the entire data warehouse. Even if you get the entire data warehouse access, what is it you do? Right? You basically, if you are from HR, you just need only HR database or HR data mart access, not the entire data warehouse, right? Okay, so we'll talk about the rest of the concepts of SQL, right? And then we'll go through the introduction to Power BI. And tomorrow, end of the day, I'll show you from where you can install Power BI, and also how there is something called Power BI service registration. But at this point, it is not needed. I'll let you know when to create your Power BI service account also. At this point, not needed. Okay. So it's very easy to install. I'll cover that tomorrow. Right. With that, think all of you are good with normalization, denormalization, foreign key, primary key, right? Join, relationship, VLOOKUP, right? This basic terminology. Great then. So let's catch up tomorrow. I'll upload this material in the Google Drive. Please make sure you download it and be ready for tomorrow's session.
Thank you, sir.
Yeah, thanks everyone. Bye.